In today's talk, we're going to look at Pascal's triangle again. And the main point of the talk will be to introduce a problem I want all of you to be working on this weekend and try to come to our class meeting, our Zoom meetings on Monday, and we'll talk about what everybody found at that time. So we'll start with Pascal's triangle. All of you are very familiar with Pascal's triangle, starting 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, etc. These contain the combination numbers, as all of you remember. So for example, in row 4, we're starting with row 0 here, we have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And one thing that you'll notice about the numbers in Pascal's triangle, and this isn't surprising, some are even and some are odd. Here's a question. Are there interesting patterns in Pascal's triangle about which numbers are even and which numbers are odd? Well, let's start. I'm going to draw a new Pascal's triangle here, but instead of putting the exact number like 2 or 3 or 4 or 6 or 5 or 10, any of those, I'll just put whether it's even or odd. And I'll just put a 1 if it's odd and a 0 if it's even. In other words, we're thinking of these numbers mod 2. Every number either leaves a remainder of 1 or 0 mod 2. The odd ones are 1 and the even numbers are 0. So we start with 1, and you could either look at Pascal's triangle and then figure out whether the number is even or odd and put that there. Odd, 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 even, odd, 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 odd. Or let me tell you what you can do. If you're creating the triangle from scratch, instead of adding the numbers like 1 and 3 and getting 4 and then seeing that that's even, you can just look above here and use the rule for creating Pascal's triangle that the number we put on the next row is the sum of the two numbers above it, but just interest yourself in parity. We start with a 1, which is odd. 1 plus 1, when you have two 1s there, that's the sum of two odd numbers, which is even. So you just use the rule, 1 plus 1 gives you 0. 1 plus 1 gives you 0, 1 plus 1 gives you 0. That 1 plus, think of a 0 outside, gives you 1. And that's exactly this row 4, odd, even, 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 odd. The next row, just using our rule to create it here, we get a 1, we get a 1, then we get a 0, 0 plus 1 is 1, and 1. So we get that pattern. And finally for row 6, we start with a 1, then we get a 0, then we get a 1, then we get a 0, then we get a 1, then we get a 0, then we get a 1. And you can keep going on and on. I'll show you the next row without computing exactly row 7 of Pascal's triangle. The next row here would be 1, 1, 1, 1, 1, 1, 1, 1. Look at that, all 1s. So here we have 8 rows of Pascal's triangle. Row 0, row 1, row 2, row 3, row 4, row 5, row 6, and row 7. And you might already see an interesting pattern that's developing. Here are the questions I want every single one of you to work on for Monday, and I want us all to be able to talk about them in class on Monday. First, I want you to continue this process and find a large piece of paper. You can do this just on a regular 8.5 by 11 sheet of paper, but even better if you have a bigger piece of paper, you can go further. Extend this new version of Pascal's triangle, indicating just even or odd with 1s or 0s. Or sorry, even or odd with 0s or 1s, 0 for even, 1 for odd. Make it go to at least 16 rows. 16 rows at a very minimum. That's row 0 through row 15. We did 8 rows already, so that's not a whole lot more. But try hard to extend it further. If you can go all the way to 32 rows, the numbers get very large if you're producing a regular Pascal's triangle up to 32 rows. But if you're just counting even or odd, every entry is either a 0 or 1, it's much, much, much simpler. So try to produce this as large as you can and keep things very neat and orderly so that you can see any patterns that happen. Then what I want you to do is figure out, or just make a conjecture, for how many odd numbers, how many ones you have in Pascal's triangle at different stages with different numbers of rows. A good example would be, look at the first 2 to the n rows, row 0 through row 2 to the n minus 1. Let's take a look above. I'll come back later. Here we have 8 rows of Pascal's triangle, row 0 through row 7. That's 2 cubed, or 8 rows. Count how many ones we have. Well, that's easy to do. We have 5, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. We have 27 ones. And how many zeros do we have? We have only 6, 7, 8, 9. 9 zeros. So in these first 8 rows of Pascal's triangle, we actually have 3/4 of the entries are ones, and only 1/4 of them are zeros, meaning 3/4 of the numbers in this Pascal's triangle, if I went to the next row as well, which I won't write down here, 3/4 of those numbers would be odd, and 1/4 would be even. Here's my question. What happens as you get bigger and bigger versions of Pascal's triangle? Do we still have more odd numbers than even numbers? Conjecture a formula that tells you exactly how many odd numbers you have in the first 2 to the n rows. See if you can guess for any number n. For n equals 3, we just wrote down the answer there. Question to you is, what fraction of the first 128 rows, 128 of course, is 2 to the 7th. What fraction of the entries are odd in Pascal's triangle? In other words, how many are ones? Not just how many, but what is the number of ones divided by the total number of entries in Pascal's triangle? That's like asking, among all combination numbers, m choose n, where your m is at most 7. I'm sorry, not most 7, at most 128. We're going all, 100, let me say that again. If you look at all combination numbers, m choose n, where m is at most 127, that would be for row 127, and you allow any eligible n, that means the n's go from 0 up to m. What fraction of those are odd and what fraction are even? And then ask yourself, what's the limit as n goes to infinity for this previous question? If you look at the fraction of odd numbers to total numbers, or even numbers to total numbers, what can you say about the fraction of entries which are odd up to row n as n gets bigger and bigger and bigger? I'll leave it there for this video lecture, or question really, this video question. Be sure to work on it on the weekend, and we'll talk about this more on Monday.